Graphene-like nanoparticles of molybdenum and tungsten dichalcogenides, new opportunities of nanocomposite design. Konig Natalia, Francevich Institute for Problems of Material Science, NASO of Ukraine. So there's plan of my presentation, introduction, basic tendencies of nanocrystalline studies, perspective multifunctional 2D nanomaterials on the base of graphene-like molybdenum and tungsten dichalcogenides, then experimental pattern results, nanosynthesis of graphene-like, transition metal dichalcogenides nanoparticles, oxidation in the air of graphene-like tungsten disulfide, and the result of X-ray studies of obtained composites on tungsten disulfide, tungsten oxide, like core shell, and conclusions in the end. So, the intense investigation of synthesis of new transition metal dichalcogenides nanoparticles and nanotubes, onion-like structures, nanorods, nanoribbons, nanovirus, quantum dots, and others begin from 1992 and carry out. And the undisputed leader among refractory compounds nanotechnologies is EF nanoparticles of the transition metal dichalcogenides. Centers, scientific centers situated in the USA, Israel, China, Great Britain, Japan, India, and others. And main objects are fullerene-like nanoparticles of tungsten and molybdenum disulfides. But there is a problem that there is no enough amount of homogeneous samples, so it is disadvantages limit innovation, development of fullerene-like nanoparticles and nanomaterials on their base. From 1911, special attention was attracted by investigation of two-dimensional graphene-like nanoparticles of transition metal dichalcogenides, because they have 2-dimensional structure and they are inorganic analogous of graphene, and namely two-dimensional of such structures leads to a number of unique structural sensitive physical properties, which are qualitatively different from graphene and multi-valve carbon nanotubes. Centers are situated in Great Britain, Switzerland, Ireland, Korea, Singapore, Taiwan, Japan, and others. And main objects are nanolayers and graphene-like nanoparticles of disulfide molybdenum. Characteristics of graphene-like research are common interdisciplinaries of 2D nanomaterials, graphene, graphene-like, molybdenum, disulfide, and their nanocomposites. Organization of new laboratories, attraction of scientists from different scientific centers, and financial opportunities, high competitions, mobility, and landmark publication. There was, for example, 3 press releases in 2011 and 1 in 2005 about nano-armor. So graphene-like nanoparticles of molybdenum and tungsten dichalcogenides have prospect of nanomaterials design for various purposes. There are nanomaterials for energy converters in chemical current sources, photointercalation solar energy, and solar batteries, hydrogen nanomaterials and sensors for hydrogen energetics. Nano-armor, it is nanomaterials as shear shock absorbed at very high pressure. Heat insulate nanomaterials with record low thermal conductivity. Magnetic two-dimensional nanomaterials, photocatalysis on semiconductor nanoparticle, they use invisible spectrum, and application for hydrogen energetic ecology treatment wastewater, and sensibilization of another nanocatalysis. And of course, nanolubricants. There is solid radiation-resistant electroconductive nanolubricants for different applications in space and ground-based operation conditions under high and low temperature, hydrogen atmosphere, and medical equipment. Like additives to industrial oils and greases for improvement of their tribochemical parameters. Of course, in comparison with using of natural molybdenum disulfide micron powders. Fields of applications, aerospace and mechanical engineering, oil and gas complex, transport, military hardware, and metallurgy. And these applications fields can be expanded by the use of composites on the base of graphene-like nanoparticles of molybdenum and tungsten dichalcogenides. Considering features of their real structure, can be expected synergy effect for structural sensitive physical properties. I need to say that new application fields last 3 years add chemical current sources, excellent electrochemical performances, lithium batteries and supercapacitors, nanoelectronics, for example, field transistor use in 100,000 times less of energy than silicon transistor, and cheap and are more miniature and flexible. Also, semiconductor nanomembranes, fields of application, mechanical and thermoelectrical devices, nanoelectronics, optoelectronics, photonics. And the last year add nanosensors, memory devices, nanophotovoltaics. And of course, special interest nanocomposites. There is biocomposites and composites for medical therapy and anti-friction coating. So, scheme of experiment show on the slide. We take graphene-like nanoparticles. Graphene-like nanoparticles of molybdenum and tungsten dichalcogenides were prepared by laboratory nanotechnology using chemical vapor deposition, CVD. This button-up nanosynthesis or layer-by-layer assemblage of metal chalcogen nanosheets able to prepare homogeneous graphene-like nanoparticles in sufficient amount, and they have small average sizes, order of 1 nanometer in crystallographic direction 0.13. And the prepared graphene-like nanoparticles by their chemical composition, structural type, and nanostructure pattern are homogeneous and did not contain foreign phases, including X-ray amorphous one. The average sizes of anisotropic nanoparticles of the molybdenum and tungsten dichalcogenides are effectively adjusted in a wide range. So we take the initial nanoparticles with average sizes, and after oxidation reaction goes by these reactions. X-ray studies fulfilled by automated powder diffractometer with use of full profile analysis, Rietveld method, and package software of structural calculations. And the result of X-ray studies of the oxidation products of graphene-like tungsten disulfide in the air established that oxidation occurs to the formation of tungsten oxide, tungsten O3. But if the oxidation incomplete, we can obtain composites, and X-ray result show that that incomplete products of incomplete oxidation of graphene-like tungsten disulfide in the solid phase are heterophases and contain tungsten disulfide like a core and tungsten oxide like a shell. So in the middle there is tungsten disulfide and okay, and shell there is tungsten oxide. So there is a result of X-ray studies of composites, tungsten disulfide, tungsten oxide, and you can see with the increasing of temperature, there is also X-ray results of X-ray study. There is a comparison and experimental calculated profiles of diffractograms and crystallographic data for tungsten sulfide and tungsten oxide. So when temperature increase, the structure tungsten disulfide decrease and proportion tungsten oxide is increased with the increasing of temperature. So it were prepared composites, but with average sizes of particles more than 200 nanometers, unfortunately. And it was established that some distortion structures of composites, tungsten disulfide, tungsten oxide, are interconnected. The increase of temperature oxide leads to an exponential decrease of the unit cell parameter A and C in the composite. Unlike to micron powders, where parameter A and C are independent of temperature oxidation. There is result for wolfram tungsten oxide composite. Parameters A and C decrease, and parameter B increase, and angle B also increase. That is temperatures of the beginning of oxidation in the air of disulfide tungsten powders practically does not change at the transition to the nanocrystalline stage. There is only 30 degrees differ, and it is important factor for their practical use. For example, for design of nanocomposites like charcoal, tungsten disulfide, and tungsten oxide, and for new multifunctional nanomaterials on the base of graphene-like nanoparticles. So, conclusions: composites, core shell, tungsten disulfide, and tungsten oxide were obtained by incomplete oxidation of graphene-like tungsten disulfide in the air. Graphene-like nanoparticles of molybdenum and tungsten dichalcogenides are perspective for design of a new generation of nanocomposites, including semiconductive nanomaterials for different applications. Performing of further systematic research is necessary for create nanocomposites with control structural sensitive properties. Thank you for your attention.
question. One question. I have some question about graphene-like particles. What means exactly? What size of these nanoparticles in one dimension?
Graphene-like nanoparticles, there is two-dimension layered materials and average sizes of prepared by our nanotechnology, laboratory nanotechnology, order of 1 nanometer. It's mean in direction 013, there is for tungsten disulfide there is 2.5, and may be controlled by temperature of annealing.
2.5 nanometer?
Nanometers, yes, and in the crystallographic direction 110, it from 8 to 50 nanometers.
Okay, thank you.
Thank you.
I asked lecturer